Anit Pelev. I've just graduated from Shankar College of Design. I wanted to create a ready-to-wear collection printed entirely at home, using printers that anyone can get. I've spent the past year searching for the best solution. I worked with leading experts in the field. I really like the result. It looks a little bit like lace. And it moves beautifully. Just imagine the potential. If you're called to print your own jacket, traveling with no luggage, just print your clothes in the hotel room. Will we soon be able to design, share, and print our own clothes directly from home?
This is a Razor 3 3D printed, fully autonomous UAV. It's built from completely off-the-shelf hardware, so the brains of the unit is a cell phone, 2 batteries, and an electric ducted fan. Our first launch was a car launch. We lifted off out of the sunroof of my car at about 25 miles an hour. The second launch we moved to a bungee cord and launched it off the ground. And we've just gotten to the point where we're hand launching.
It was designed to be hand launchable. That's been one of the major constraints all the way from the very beginning. It's going to take a leap of faith when we finally do it.
3, 2, 1.
Yeah, give me a wing.
3, 2, 1.
Taking a beating though.
Yeah.
I teach a few courses here at the university on jet engine design and manufacturing, where we actually design and build a jet engine and 3D print it. The first year I did this, one of my students took a video with a cell phone and that night put it on YouTube. Some folks at MITRE happened to see that video. They were looking around for someone that could help them to design and build a fully autonomous 3D printed airplane. And we started out with a somewhat conventional airplane just to prove that you could 3D print something that would fly. And we've moved on to our Razor here. It's a flying wing configuration and it flies up to and over 100 miles an hour, but it really finds its sweet spot around 40 miles an hour.
Because of the autonomous nature of the plane, we needed to be able to do onboard calculations. And MITRE has been working with this technology package where you have a cell phone, an Android cell phone that's actually the brains of your electronic operations. What this allows us to do is to kind of hijack the processor and the memory of the phone. We use the camera, and you can use 3G LTE connectivity in the cellular network.
This aircraft is really designed around 3D printing, but what it's trying to showcase is what's generally referred to as rapid prototyping. We have full control of the design. We design it on a CAD program. We can change and modify the models any way that we choose, and we can do it very quickly.
We decided that it would be pretty much impossible to hand launch with our original motor just because it wasn't putting out enough thrust. What it came down to was a lot of iterations of printing to try to get the tolerances and clearances just right.
The problems you solve on real-world problems like this are not like textbook problems where you know the answer's in the back of the book and you just have to try to get that answer. A lot of times you don't really know what the problem is. The solution is very nebulous. You have to figure that out yourself. So every one of those solutions is your own, and you feel pretty proud about it. You get a thrill out of it when you see it actually flying and realize that all those little steps, every decision you made along the way really ended up being the right choice.
Woo! Go ahead and fly it if you want.
I'm Jonathan Brand. I'm an artist working in New York and New Haven, Connecticut. I didn't start 3D printing until about 3 years ago, and then shortly after I came up with this idea to 3D print a full life-size motorcycle. This is a 1972 Honda CB500. What originally interested me with Ultimaker was, at the time, I contacted them 2 years ago. It had the biggest build volume and fastest printing ability. It's open source, so users have uploaded custom parts to the printers, or all the source files for the printers online, allowing me to design and engineer my own parts for it. Everything's printed really, really thin so that it retains its transparency. And to do that required, printing these really large prints that take a really long time to print. So even this seat, which is 24 inches long, there's 1, 2, 3, 4, 5, 6, 7, 8 pieces. So I was able to highly customize the printer for my own output. So with 3D printing, I can draw something on the computer and almost immediately realize it in real life. So it goes, computer model. Then I have to bring it through a slicer that would slice it up. And then that communicates, sends it to the printer prints it in PLA plastic. The motorcycle came about because I've always wanted to own a motorcycle, but kind of life circumstances have always gotten in the way. I could never have it. And so I decided that I was just going to make one. I spent hours and hours kind of tinkering with the printers, cutting, welding all the pieces together. And in the end, I get this kind of surrogate object. All the prints I made were between 4 to 12 hours, sometimes going overnight, 24 hours. In the end, I used 18 rolls of plastic, so that comes out to be about 18 kilograms of plastic in the entire motorcycle. And you can see, throughout the bike, there's little numbers. Everything was printed, numbered, cataloged, put in a box, and then even a year later, I would assemble it. Sure, I made it really thin and really fragile so that it would be transparent, and that really pushed, the technology to its limit. I could squeeze these and crush them. Everything's like a millimeter thick. The tires turn, the steering wheel turns. I designed in different parts like bearings and things like that would enable things to turn. I like the fact that we could roll it through the room. But the end result, overall, I think is really, beautiful and effective.
My name's Dan Campbell. I'm an aerospace research engineer at Aurora Flight Sciences, and this is the world's first 3D printed jet-powered aircraft. Our goal with this project was to show the aerospace industry how quickly you can go from designing, building, and flying a 3D printed jet-powered aircraft.
My name is James Berlin. I'm an additive manufacturing research engineer at Stratasys. Aurora Flight Sciences is really pushing the boundaries of what's possible with flight. Stratasys, on the other hand, is pushing the boundaries of what's possible with additive manufacturing, so it's really a great relationship.
Recently, we decided to really see how far we could push the envelope. No one has 3D printed an aircraft this big, this fast, and this complex.
Stratasys 3D printing can address these challenges through design freedom. Design freedom can help, number one, with weight, so reducing the weight of components to meet stricter fuel requirements, and also by creating components that have higher levels of functionality or higher levels of complexity than what's otherwise possible with other technologies. One of the things this aircraft represents is the ability to make a mission-specific aircraft. We can really create an aircraft that's designed to do one specific thing because the cost of producing a one-off aircraft with additive manufacturing is significantly less than with other traditional manufacturing processes.
Just as much as cost, we're saving on schedule. I think that's really where the technology shines. We're talking about a schedule that's half the design and build time of traditional manufacturing methods.
The design process was completely collaborative, so there was weekly design reviews, there's a lot of back and forth.
The Stratasys GrabCAD system allows us to manage the CAD models, to communicate back and forth design changes.
We're able to real-time track things like weight, how components fit together, and how different portions of the airplane would come along. Some of the more functional components took up to 20 iterations to get right. So in terms of time for making an iteration, because we're updating a digital inventory, it's a matter of simply replacing the CAD file. This aircraft is 80% 3D printed by weight. 100% of the parts that were printed on this aircraft were either printed at Stratasys or printed by Stratasys Technologies. This aircraft is about 30 pounds, it has a 9-foot wingspan, jet engine capable of around 150 miles per hour. This aircraft is made primarily out of FDM, ASA thermoplastic. There are also LS parts, so the fuel tank, for example, is made from LS, and the nozzle, the exhaust nozzle, is made from DMLS. It's actually an Inconel material.
In the future, 3D printing will allow the aerospace industry to build more affordable aircraft, to build more aircraft specific to certain missions, really allow the industry to be more agile. And with Stratasys, you can tell that's part of their culture.